Okay, ladies and gentlemen, we are going to finish up our graphing with secant and cosecant. So secant and cosecant graphing. The nice thing is secant and cosecant are very, very closely related to sine and cosine. Sine equals 1 over cosecant, so therefore cosecant equals 1 over sine. Cosine equals 1 over secant, and secant equals 1 over cosine. So whereas sine and cosecant go together, cosine and secant go together. They don't only just go together in properties or in symbolic language, they also go together graphically. And the graphically means I'm going to take, and to graph cosecant, I'm actually going to graph sine. Once I have sine graphed appropriately, with all of the labels, of course, then what I'm going to do is I'm going to take this sine wave, I'm going to break it everywhere it crosses the x-axis, and I'm going to turn it inside out. Okay? So everywhere it crosses the x-axis now becomes an asymptote. Because if I have sine of pi, sine of 180, that means the opposite side is adjacent, the hypotenuse is 1. Well, that means the cosecant of pi is 1 over 0, so it becomes undefined. So what was a 0 is now an asymptote. What was a 0 is now an asymptote. Same thing. And where we had sine of 90, sine of pi over 2, sine of 90, was opposite 1, hypotenuse 1. Cosecant of pi over 2 is going to be also 1 of 1, hypotenuse over opposite. So this point is common between sine and cosecant, and this point is common between sine and cosecant. And so all we have to do is take this, turn it inside out, go down and just touch the old graph, come back up. Here we come up from the asymptote, touch the old graph, and go down. That entire graph is the graph of cosecant. Now the dotted line, of course, isn't included. The asymptotes are, of course, not included. So if you were just to see it by itself, you would see something that looks like this. And of course, it would repeat itself over and over and over. So that's going to be a cosecant x graph. Now, if I were wanting to do a secant, I'm going to start with cosine in the same way. And in the same way, wherever cosine is 0, secant is undefined. And everywhere cosine is 1, secant is also 1. So in this case, we're going to take this, turn it inside out. It opens down, just like that. Well, in this case, it opens up, because in this it would keep on going in the other period. Here it opens this way, and of course it would keep on going into the next period if necessary. This is an odd function because obviously they're not balanced. This is an even function, they're very much balanced. So, secant, cosecant, that's all put together. Here's what I want you to do. I want you to come up with 2 examples. Give those a whirl. Now, if we're to work on this one, the first thing we're going to do is we're going to take it and graph it. And it's going to be moved from 0, its vertical shift is up 3. 1, 2, 3. So the new center line is here. The amplitude is going to be 2. 1, 2. So I'm going to go up 2 from there, down 1, 2, down 2 from there. And because it's cosecant, it's really like a sine wave. So it starts here, it ends here, 2 pi. Pi over 2, and 3 pi over 2. So middle, up, middle, bottom, middle, dot, 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 dot. But now, that is sine. I still need to shift it over pi over 2, because I have a horizontal shift, even though my frequency is just 1. So horizontal shift of pi over 2, so it starts here, hits top, hits middle, hits bottom, hits back, there we go. And now, wherever the final graph crosses the center line, I have an asymptote. And I turn them around. One there, one there. And that's the graph. I want you to do the same thing over here. Make sure you pay attention to that frequency. Now, for this one, our big thing is we have shifted down 1, 2 with a amplitude of 1. So we have here, 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 and it's secant, so it's cosine. Now, 2 of those, so here we go. And so now, before we do any more shifting, let's take this frequency of 2 and let's figure out what our period is. Now remember, because this is like sine and cosine, period equals 2 pi over frequency. And so we have, in this case, period equals 2 pi over 2, which is just pi. So the whole thing has to fit within 1 pi. So we take top, bottom, top, so it looks like this. But now that we have the period taken care of, we also need to adjust for the horizontal shift. Horizontal shift of left pi over 2. So if this was 2 pi, this was pi, this was pi over 2, now it's going to end here, hit middle here, hit top over here at negative pi over 2. So we have this. And at this point we can finally draw in our asymptotes at pi over 4, negatively speaking, and positive pi over 4, and there we go. Looks just like that. So, a lot of drawing, but nothing that terribly difficult. All right, take a look from there.